anybody willing to volunteer to read the information in the box? Anybody willing to volunteer? Thank you, Chris.
Pepsi ran a promo contest for their 20-ounce bottle of soda. Some of the caps said, "Please try again," while the other said, "You are a winner." Pepsi advertised the promotion with the slogan, "One in 6 wins a prize." Miss Diaz? Okay. Statistics class wonders if the company claims is true. To find out, all 30 students in the class go to the store and each buys one 20-ounce bottle of soda. 2 of the students get caps that say you were a winner.
So 2 of the 30 students got caps that said you're a winner. The slogan is 1 in 6 wins. How many winners would you expect out of a class of 30 if 1 in 6 wins? 5. We would expect 5 winners. Why? Yeah. So in this case, we would use 30 divided by 6, or another way of taking that same idea is n times p. N would be the number of trials. In this case, that would be how many bottles of Pepsi were purchased, 30 bottles of Pepsi. And P is the probability of a favorable outcome, winning in this case. So we would do 30 times 1/6, and you get 5. Is that 5 winners guaranteed? No. You are not guaranteed to get 5 winners. Not guaranteed to get 5 winners, but they only got 2. Does the result of getting only 2 out of the 30 students give us convincing evidence that that company's 1 in 6 slogan is inaccurate? I'm not sure. Like, it feels a little low to me, but I'm not sure if that means that it's inaccurate or if we're just in, the smaller number of trials. Remember, in the short run, probability is unpredictable. So we're going to perform a simulation to help us answer this question after this announcement. All right, so we're going to perform a simulation to see whether or not this claim is likely inaccurate. We can't necessarily say, yes, you're definitely lying, but we could come up with some evidence to show whether this was just by chance or whether this is so unusual that we would say, I don't think you're being honest with your slogan here. So we're going to start with the assumption that Pepsi is telling the truth, that it's a 1 in 6 chance. If they're telling the truth, what's the probability of getting 2 or fewer winners in a class of 30 purely by chance? Let's talk about how we can set up this simulation. Oh, they're just checking the door. All right. What could we use to model a 1 in 6 chance? A 6-sided die. That would be great. As long as it's not a weighted die, we've got an even chance of getting any one of those 6 numbers. So I'm going to pass some dice out. So I'm actually going to write this down first. Roll a die. We need to decide ahead of time what is going to constitute winning in this case. We've got a 1 out of 6 chance of winning. So we need to pick one of these 6 numbers as our winner. What do you guys want to be winning? 4. God. I'm hearing a whole bunch of different numbers. Quick show of hands. Who wants it to be 2? Because that's the first number I heard. Who wants it to be 4? All right, we're going to go with 4. Sounds good. Take a die, pass it down for me. All right. So we're designating 4 as a winner and all the other numbers as loser. So we're going to write that down. Let 4 equal winner. And all other numbers equal loser. Does it matter which number we choose on the die? No. As long as these are fair, unweighted die, we should have an equal chance of getting any one of these numbers. How many students did the teacher have in her class? 30. So we're going to do a simulation of 30 trials. You're going to roll the die 30 times, and you're going to record how many 4s show up. So you're going to need some scratch paper somewhere because you want to record each of these, and you need to keep track that you've got 30 trials. We're going to run this 2 times. So roll the die 30 times, record those results, count the number of winners, count the number of 4s. Write that on the first line. And then you're going to do the same thing again. You're going to roll the die 30 times, record the numbers, write down how many 4s you get. You're going to write that on the second line. So you're going to roll the die a total of 60 times. Take a couple minutes to do that, and then I'll give directions from there. My first trial of 30, I got 3 winners, and then I'm going to do it again. Second time around, I got 10 4s on my trial of 30. I kept getting 4. All right, so I'm going to bring around blue dot stickers. You're going to go over to the dot plot over here where it says Pepsi promo contest winners. Since we've got whole numbers, they should just be stacking up in a tall line. There shouldn't be any out of line. You're going to put a dot on the first one. How many winners did you have in your first set of 30? How many winners did you have in your second set of 30? So far, so good? All right. And then once you do that, I want you to sketch the dot plot once everybody's got their stickers up there. So you want to go ahead and start sketching that. So everybody gets 2 blue dots. You're going to put 1 dot on how many winners you had in your first set of 30, and 1 dot on how many winners you had in your second set of 30. I hardly got any 4s at all.
I got 1 picture.
Oh my goodness. Here. I'm going to put 1 on the 3 and 1 on the 10. By any chance, did anybody get more than 15? Because I only took the number line out to 15. Oh, thank you. My big gigantic die. I'm going to send around my gigantic die container here. Once you're done rolling, if you wouldn't mind putting your die in there and then passing it back, and we'll get it around the room to get all those collected, please. Oh. not the only one with 10. Awesome, I think we've got everybody's dots up there. The die container should be moving around the room so we can get those collected. And I want you to go ahead and copy the dot plot into your notes underneath number 6. All right. So, what percent of the time did we have 2 or fewer prizes won out of a random trial of 30? Where would I be looking on this dot plot?
4.
Yes. Well, 2 or fewer.
Oh.
So I'm looking at, everything down here. So we had 6 out of, how many trials do we have here? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. So 6 out of 44. So 6 out of 44. Can somebody grab a calculator and tell me what that would be as a percentage? 13.6% of the time. Before we move on to the next question, I just want to revisit what each one of these dots is representing. What does this dot right here at 9 mean? Yes, there were 9 winners, or 4s rolled, out of 30 die rolls. So each one of these dots represents a trial of 30 die rolls. And in 13.6 of those trials of 30 die rolls, we got 2 or fewer winners. Does it seem plausible that the company is telling the truth, but the class just got unlucky? Yes. At what percentage right here would we start to say, we've got convincing evidence that Pepsi is lying to us? What's our break point? 5%. If we get something smaller than 5%, that's when we start to go, I'm not so sure. I feel like we have convincing evidence that they might not be telling the truth there. So I want to interpret this percentage. All right, does it seem plausible that the company is telling the truth, or do we have convincing evidence that Pepsi is lying? We do not have convincing evidence that Pepsi is lying. There is a 13.6% chance of getting 2 or fewer winners in a class of 30 purely by chance. And what I'm going to write off to the side here, 13.6% is greater than 5%, so it is not statistically significant. When things happen less than 5% of the time, that's when it sends our radar up. More than 5% of the time, it's probably just due to chance. Do you guys have any questions before we look at our big ideas for today? All right. Once you get our big ideas written down, I do want you guys to go down and try to answer the questions that are in the Check Your Understanding section. So our big focus today was on this idea of a simulation. We're going to imitate chance behavior based on a model that accurately reflects the situation. We could do this with a dice roll, with a coin flip, with a random number generator. We could use an applet, but we want to use some kind of model that accurately reflects the situation and allows us to incorporate chance. The process for simulation, we want to describe how we're going to simulate one trial or one repetition, and then we want to do many trials. I had each of you guys do 2 trials, but that meant as a class we came up with 44 trials. So we repeated this many, many, many times. And then we used those results to answer our question about whether or not this was likely due to chance. So get those 2 big ideas written down, and then I want you to come down and do the Check Your Understanding. About 6-ish minutes, 7-ish minutes, so you have enough time to write and then think on those problems, and then we'll talk about the Check Your Understanding section. All right, so let's talk through our Check Your Understanding. 3 questions down here. Some people have wondered if the wheel in Wheel of Fortune is fair. If it's fair, bankrupt should result in a probability or should occur 1/9 of the time. To test the wheel, Pat Sajak observed a random sample of 50 spins of the wheel and found that bankrupt was spun 10 times. Is this convincing evidence that bankrupt comes up more often than it should? How would you carry out a simulation? Let's talk about just the simulation process, assuming it's due to chance. Walk me through this.
I said I would set up a random number generator and have it set up for 1 to 9. And then I would pick the number 2 to be the bankrupt thing. And then I would use it 50 times to see how many times I got 2.
I like that. That describes my first trial. I set it up almost exactly the same. Use a random number generator. We want to create a list of 50 integers, 1 through 9. I picked 1 to be bankrupt. You picked 2. Same idea. You got to pick one number to be your bankrupt out of those 9. You're going to count how many 1s show up in the list out of our list of 50 integers. So that would be one trial. That would represent 1 dot. What would I want to do after this? Do it again, and 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 again. We want to repeat this many, 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 many times. And then after I repeat this over and over and over, I'm going to estimate the probability of getting 10 or more bankrupts in 50 spins, just like we did with our die rolls. So if you look at the dot plot that's a little bit more than halfway down the page, they went through this process that's described here. And they did their trial 100 times. So they did 100 trials of 50 spins using that random number generator to determine number of bankrupts. There's a dot out there on 12, on that dot plot. What does the dot on the 12 represent? I don't have the dot plot up on the screen right now, but if you look at your page, there's one single lonely dot out on that 12.
50 rolls landed on 12 times.
Yes, we came up as bankrupt 12 times in one trial of 50 spins. I don't want to scoot past this too fast. If you guys need to grab a quick screenshot so that you can copy this down, please feel free. Yeah, that one dot on the 12. In one simulation of 50 spins of the wheel, there were 12 bankrupts. However, bankrupt was described. In my simulation, I had that being symbolized by a 1. In Muhammad's, he had it as a 2. Maybe you picked 9 to be your bankrupt number, but that appeared 12 times out of 50. Just by chance, purely by chance, because we were using a random number generator. Looking at this dot plot, that is the result of 100 simulated trials, using a very similar process as to what was described up in Part A, what can we conclude about 10 or more bankrupts? What percent of the time did that occur? 4%, because we've got 3 dots on the 10 and 1 on the 12, so we have 4 dots out of 100 that are 10 or more bankrupts. Is that enough to pique our interest, to grab your attention?
Yeah.
So would you say that this is a fair or an unfair wheel? Unfair. Assuming that the wheel is fair, there's about a 4% probability of getting 10 or more bankrupts in 50 spins. Because this is unlikely, less than 5%, we do have convincing evidence of an unfair wheel. Is that the same thing as accusing them of it being unfair? No. We have evidence to suggest that it's unfair. Further repeated trials would be needed, testing would be needed, but we have enough evidence to continue on with our investigation to say that this is likely not just due to chance. Yes, sir.
So I thought it was, yeah, more than 5%.
So if something occurs less than 5% of the time, in this case we had rolling 10 or more bankrupts as being the event that we're looking at, and it's very unlikely to occur if it's just due to chance. So using that random number generator, we got 10 or more bankrupts only 4% of the time. that's enough to send our radar up and to say, I don't think that this is a fair wheel. A fair wheel means purely by chance. These things are occurring just by chance. If it's occurring more than 5% of the time, just due to chance, that doesn't send my radar up. That's probably a fair wheel, and what we observed was just bad luck. If it happens less than 5% of the time, you're like, I don't think this was just my bad luck. I think you have a rigged wheel. Does that make more sense? Okay. Oh, I think I get where your confusion is. We want to say if it's due to chance and it happens less than 5%. But in my experience, it happened quite often. There, yes, that's, depends on like which side of the coin you're looking at. We're going to stand on the side of pure chance. And if it's not likely to happen just due to chance, that's when we're like, I think there's something going on. Right. Yes, ma'am.
Is the rule for statistical significance flexible? Like if you get 6%, would that still be like sort of like there might be evidence or?
So I mean, we really kind of pick a cutoff point in statistics, and 5%, while not being arbitrary, that's usually where like natural human curiosity is saying, I think something's up here. So 6% of the time, we would still fall on the side of saying we don't have convincing evidence. Next semester, when we get into hypothesis testing and stuff, sometimes that line does have a different break point, and we'll talk about that further. But yeah, 5% is really our cutoff. Specifically less than 5%. So if it happens 5.1% of the time just purely by chance, we're like, it's probably due to chance. Good questions, good questions. First homework assignment. Guys, first homework assignment is due tomorrow evening. Don't forget to do that. It's that front back. Make sure you upload that to Canvas. Tomorrow I will pass out your next homework assignment for this unit. Remember, this is a really short unit. When is our test over this? Next Friday. So we're going to be done with material like very beginning of next week.